Hi, my name is Jace Butcher. I'm going to be attempting to make a YouTube video for this ADJ assignment number 1, problem number 2. If you go ahead and follow along with me in my second submission of the PowerPoint, I will be starting on slide number 2 with the problem statement. So the problem statement is basically we're going to be taking a video file and compressing it for a cartoon. Each image in the video file will differ from frame to frame. What we want to do is do two things: determine the difference from file to file, image to image, and then save the difference, I assume to a value or to some sort of database. They're going to be large images, and we're designing a compression mechanism to do this. It's also going to be multi-core programming, not single-core programming. This is assuming that we have 5 main issues in multi-core programming that can be found through my own research. I found those 5 issues to be identifying work and tasks, balancing work, data splitting, data dependency, and debugging/testing as well. The 3 assumptions that will be made is that we're using multi-core programming, not single-core programming. There will be multiple functions and tasks. I outlined those 2 earlier, those being determining the difference in images. The second is saving the difference in images. The 3rd assumption is that there are 5 core issues in multi-core programming to be identified and discussed. I've outlined those already, and I will now go ahead and discuss those in a little bit further here. So onto the requirement slide number 3 on my file here. First, the selection of the most problematic issue arising from compressing a video and saving the differences must be selected based on a figure of metric. Basically, I'm not arbitrarily making a case for a random issue and downplaying the others with no sense of measurement. I plan to outline that in the next few slides here and then analyze them individually. Each issue must be discussed at some length. I do want to go through each individual issue in multi-core programming rather than just taking the one that I chose as the most problematic and leaving out the others. I feel like it's good to kind of justify why I chose that and why I didn't choose the others. Third, that this compression mechanism being designed is using multi-core programming and not to make any assumptions that would be used in a single-core programming project, which I think is kind of bound to happen. I'm going to try my best not to do here. Fourthly, the selected option will be justified through analysis and critical thinking. Keyword there, critical thinking. This took a lot of research and analysis to do, as well as just understanding multi-core programming as a whole, as well as this specific scenario at hand, and that I'll use critical thinking to come to my conclusion, which I believe I did here. I'm moving on to the 4th slide here, the justification methodology. So I have 2 things that I'm going to be considering for each issue here. 1, how will data be affected? 2, development work. Will there need to be more development work to tackle an issue like this? How much? How much time will it take? These are prioritized from top to bottom. Therefore, I'm going to be taking data into consideration more than anything, just being if we don't have the right data or if the right data is manipulated at the wrong time, it's going to cause errors in our project. It might not cause compilation errors per se, but it will when saving the file, we're going to have incorrect data, which is a failure overall. So I think data is the most important, and then performance and development work will be number 2 on the priority list. The figure of metric, I'm going to make up for that prioritization by grading data from 1 to 10, while I'll be grading development work from 1 to 5. This gives data the ability to basically go up to 10, obviously making it double as important as development work. So for this project, I think that should suffice as a justification. So we'll go ahead and move on to slide number 5 here for my analysis of each issue. The first issue being identifying tasks. This is obviously crucial to the success of any multi-core programming project, being that we have to identify which tasks and then that we need to separate and if we should separate them as well. I think those 2 tasks in this outline scenario will be determining the difference in images, and then the second one is saving the difference in images. So this is a bit complicated as we have to decide whether or not we want to separate the cores for each operation, but overall I think this is something that won't affect data at all. It might take a bit of development work and even some type of meetings, but this does not seem like it's going to be the most impactful or most crucial issue that will arise in multi-core programming. Its brother, however, balancing the work between cores is a little bit more complex, just considering that we need to determine whether or not certain operations are important enough to justify splitting them up. So, the save operation, I'm not sure how much power or performance that would take. That might just exist in the same realm as the determining difference core. I'm not sure. I'm sure that we'd probably end up separating those just for design choices, but as far as the data goes, I'm not sure, and that's why this one's a little bit more complicated, but overall I think absolutely doable for this scenario. The next one is one that I definitely considered being the most problematic. Overall came to choose that it's probably not going to be, and that's data splitting. This is similar to balancing, but instead of balancing tasks and splitting up tasks into different cores, it's splitting up data. Deciding if it's worth it to take data and divide it by cores as well, which I think that we'll definitely be doing in a project like this, just being that obviously we have two operations that are doing two different things parallel. So we would obviously need to save different data to different places to do those operations. So the fourth one and the most important and crucial, this is, spoiler alert, this is the one that I chose as my most crucial. That's going to be data dependency. So this obstacle involves both data and development time. The execution of these tasks, if it's not done synchronously, everything's going to screw up. We need the data to not be stepping on each other's toes in some sense. Even if the data is correct when it enters, we have a fine video and the image files are there through transitions. If those are messed up throughout, the transitions and we're stepping on each other's toes, the data is not going to be correct. The data is not correct, the project does not work. We're going to need development time to figure out algorithms here to split those up. It's going to involve the prior mentioned 3 tasks here. Those all have to do with data dependency in some sense, just being that we're going to need to consider the data dependency through each of those tasks. If we split up data, you have to decide, is that going to be dependent on the other data in the other core? Same with identifying and splitting up tasks as well. So this one definitely seems to be the most important in my opinion. And I'll go through debugging as well just to give a rundown there. I see this coming into play only if the other 4 aren't handled correctly. Otherwise, I don't see debugging being the most crucial to look at. Going on to my graph on slide 6, I just included this so you can see the number of threads with job execution times. This goes ahead to see that basically don't use too many threads. Don't separate cores when you need to. So now the grades that I gave, I can go through these quickly here. Identifying tasks, I gave a 3 in development work and 1 in data. Data splitting, I gave that a 7 in data, 4 in development work. Testing, I gave it a 1 in data, 5 in development work. Balancing, a 3 in data, or a 3 in development work as well. Data dependency got the highest score, it's a 16, 9 in data, and a 7 in development work. Those scores are based on difficulty and how we're going to overcome them, basically. So my justification for choosing data dependency is that this single process of determining the difference frame by frame while also saving the differences, this is parallelism. This is doing 2 things while running one process. Being these different tasks depend on the same data, it's crucial these tasks don't manipulate data in the wrong order or wrong time. If that's not happening, it will basically create bugs within the program. These bugs can be difficult to debug, which is issue number 5. And it creates all types of other issues that are hard to test and find throughout the program. It's not ensured that the tasks completed are a synchronized manner, and this instance of data dependency will definitely cause very severe problems in our program. Designing a program to satisfy the problem statement's requirements would likely involve a combination of task parallelism as well as data parallelism. There would be multiple tasks running at the same time on the same subset of data while also distributing the data across cores. I believe considering these 2 terms, it will be data dependency that is the most difficult to overcome, as each of the other tasks can indirectly impact this reality. So in summary, I think that you could have chose any of those 5 tasks that I'm sure other students made a case for. I chose data dependency, and that is what we're going with for ADJ number 2. So this is Jace Butcher. Thank you for watching, and I really appreciate it.